In this video, we're going to be working on some word problems that involve geometric figures, common shapes, and common solids. Here's problem number 1. If the volume of a cylinder is 15 cubic meters and the diameter of the lid is 3 meters, then what is the height of the cylinder? So, what we have here is a cylinder with a total volume of 15 cubic meters and the diameter of the circular base is 3 meters. Then we are asked to find its height. To solve this problem, we need a formula for the volume of a cylinder. So for a cylinder, the volume is equal to pi times its radius squared times the height. So what we're gonna do is just plug in the values, the given values, and then find the unknown value. So for the volume, we have 15 cubic meters. Then the radius is equivalent to half the diameter. So that would be 3 over 2 squared times the unknown height. So isolating the height, we get 20 over 3 pi. Or that's approximately 2.12 meters. This is now the height of the cylinder. Next, a rectangular reflecting pool with a horizontal bottom holds 60,000 gallons of water. If the pool is 40 feet by 100 feet, how deep is the water in feet? So what we're dealing with here is a rectangular solid with volume of 60,000 gallons and dimensions of 40 feet and 100 feet. We are asked to find the depth, and let's call that h. So for a rectangular solid, the volume is equal to the length times the width times the height. Alright, so what we're gonna do is just plug in the values. However, take note that the units are not the same. The volume is in gallons, the dimensions are in feet. So we're gonna have to convert the gallons first so that the units are consistent. For 60,000 gallons, using the conversion factor that for every cubic feet there are 7.48 gallons, equal to the length, which is equivalent to 100. Then the width is 40. Then the depth or the height is unknown. Solving for h, we get 2.005 feet, or that's approximately 2 feet. Next, a moving company is trying to store boxes in a storage room with a length of 5 meters, width of 3 meters, and height of 2 meters. How many boxes can fit in this space if each is 10 centimeters long, 5 centimeters wide, and 5 centimeters high? So the storage room in this case is a rectangular solid with dimensions of 5 meters by 3 meters by 2 meters. And then we also have the boxes, which are rectangular solids also, with dimensions 10 centimeters by 5 centimeters by 5 centimeters. Let's define the number of boxes as n, and then we are asked to find n, the number of boxes. To solve the problem, we are going to divide the volume of the storage room by the volume of the boxes. Since both of them are rectangular solids, then the formula for the volume is just the length times the width times the height. However, if you look at the dimensions, the units again are not the same. So we can solve in terms of meters, or we can solve in terms of centimeters. Let's use centimeters. So we'll have to convert meters to centimeters using the conversion factor that for every meter, there are 100 centimeters. Okay, so n now is equal to 5 meters, or in centimeters, that's 500. 3 meters equivalent to 300 centimeters, and then 2 meters, 200 centimeters. Divided by 10 centimeters times 5 centimeters times 5. So n is equal to 120,000 boxes. This is now the number of boxes that can fit in the storage room. Next, the height of a cylinder has the same length as the circumference of its base. Its measured height is 400 centimeters. Calculate the surface area and the volume of the cylinder. So we have a cylinder whose height is 400 centimeters, and according to the problem, the circumference of its base is equal to the height, which is also equal to 400 centimeters. And then we are asked to find its surface area and its volume. Let's solve. Formula for the surface area is equal to 2 pi RH plus 2 pi R squared. The first term, which is 2 pi RH, this is the lateral surface area, or the area of the side of the cylinder. And then the second term, this is the area of the circular top and the circular bottom. That's why it's 2 pi R squared. Notice that we cannot immediately solve for the surface area because we don't have the radius. However, we can solve for the radius using this relationship, that the circumference is equal to the height. We know that the circumference of a circle is equal to 2 pi r. And since the circumference is equal to the height, and the height is equal to 400 centimeters, then we can plug in 400 equal to 2 pi r. So solving for the radius, we get 200 over pi. We can now solve for the surface area. 2 pi r, where r is 200 over pi, times the height is 400 centimeters, plus 2 pi r squared. Again, r is equal to 200 over pi. So the surface area now is equal to 185,464.79 centimeters squared, or square centimeters. This is now our surface area. Now let's solve for the volume. Formula for the volume of cylinder is pi r squared times height. So let's plug in the values. Pi times r squared. We obtained r earlier, which is 200 over pi squared, times the height, which is 400 centimeters. So the volume is equal to 5,092,958.18 cubic centimeters. So this is now the volume of the cylinder. Next, 4 cubes of ice with an edge of 4 centimeters each are left to melt in a cylindrical glass with a radius of 6 centimeters. The question is, how high will the water rise when all the ice have melted? For this problem, we can make an assumption that the volume of the ice when it melts is equal to the volume of the water. However, in reality, this is not the case because water, when it freezes, it expands. This means that the volume of the ice is greater than the volume of the water, and the difference is approximately 9 to 10%. So let's define the given values. Let's call the edge of an ice cube as E, and it's equal to 4 centimeters. And we have also radius of the cylindrical glass. Let's call the radius as R, and it's equal to 6 centimeters. We are asked to find the height of the water in the cylindrical glass when all the ice have melted. Let's solve first for the volume of the ice cubes. Formula for the volume of a single cube is its edge cubed. Since we have 4 ice cubes, our working equation now is equal to 4 times E cubed. Solving for the volume of the ice cubes, we have 4 times E cubed, where E, or the edge, is 4 centimeters cubed. So the volume is equal to 256 cubic centimeters. Again, let's assume that the volume of the water is equal to the volume of the ice cubes. Therefore, volume of the water is equal to 256 cubic centimeters. The water will take the shape of the cylindrical glass. Therefore, our final working equation is the volume, or the formula for the volume of cylinder, which is equal to pi r squared height. Let's plug in the values. So volume of the water inside the cylindrical glass is 256 cubic centimeters. Pi, then radius of the cylindrical glass is 6 centimeters. So 6 squared times h, which is unknown. This is now the height of the water inside the cylindrical glass. So solving for h, we'll get 64 over 9 pi, which is approximately 2.26 centimeters.